So, hi everyone, I'm Michele Romani from Italy, and I'm a PhD student at the University of Trento. And at the same time, I'm also a visiting student at g.tec Medical Engineering. And so my work is divided between this lab in Trento, which is called the CIMI Lab, is the creative and interactive multisensory lab. So we are working with these multisensory interfaces, including the BCI. And then in g.tec, in which I'm working as a researcher, mostly and developer. So I will first go through a little presentation of the unicorn, because I think it's important to understand how the hardware is, and also to give you some little spoilers on what the hardware will be very soon. So the unicorn is a consumer device, so it's not targeted at medical applications. And I specify this because g.tec originally is a medical engineering company. So they have been making EEG devices for more than 20 years. And only recently, in the last few years, they opened a branch called Unicorn to target consumer device applications. So this is the unicorn, as you can see. It's a device that comes with a lot of connectors for any programming language, and most importantly, with an interesting do-it-yourself kit. So, for example, many labs acquire the naked PCB with the cables, and they build their own headset, right? So they embed it in different shapes or different configuration depending on the type of study they want to do. And the quality of data is generally pretty good. In fact, we have 8 channels, which is sufficient for most of the BCI applications, and a very high signal-to-noise ratio, meaning that the information is not spurious. It's actually mostly good information when the setup is correct. And we have these hybrid electrodes, which are a patented technology that is cool because you can decide if you want to use gel or not. So there are advantages, of course, using gel most often, but for non-lab setups, you can also just wear it and use it. So these are the electrodes. They are kind of gummy, and you can insert the gel with a syringe in this hole when it's placed on the head. And many projects have been using Unicorn. So Unicorn is out since 2018, so it's now a 5 years old technology. So we had some in many exhibitions, we had cool projects like this gin tonic maker. This was making a cocktail based on the power band features of the brain. Then we also had several artists using brain activity from the unicorn to create installations. For example, we also have a tool for painting, controllable with the unicorn, and there is a giant painting at the office made with this tool. And we also have collaborations with some artists in the fashion tech. For example, Anouk Precht is the artist who designed the first unicorn. So she designed the prototype of the unicorn. It was made for engaging with children, right? And then from this white design, we created, actually, g.tec created the more simple that you've seen previously in the picture, the black one. And so yeah, unicorn is used a lot also for research. It's been used in several studies, so you can find them when you look into papers. It's usually either the unicorn or the Nautilus. Those are the most sold devices by g.tec. The Nautilus is a more powered version of the same type of device with 16, 32, or 64 channels. I mentioned this because our main medical product is based on the Nautilus. So the product is called Recoverix. So Recoverix is a tool for neurorehabilitation. So we offer it in specialized centers. So it's not something that you can just buy and use at home, but there usually are therapists or hospitals or clinics that adopt the Recoverix tool, and it's based on the motor imagery BCI. So basically training the BCI in understanding what movement the person wants to achieve, and then the person that has lost control of one of the limbs, for example, due to a stroke or other type of neurological disorder, will be electrostimulated until the connection is rebuilt. I will show you now a quick video that basically explains this with a very simple language, I think. And I hope you can hear the audio. So if you do not, stop me, please.
You had a stroke and now suffer from limited mobility, hemiplegia, or pain due to spasticity and tremor. But physiotherapy, occupational therapy, and other conventional therapies aren't helping you. Try Recoverix. Our innovative stroke therapy combines 3 rehabilitation methods to help your brain learn new ways to move your fingers, hands, arms, and legs. The first step is to imagine a movement. If your hand is impaired, for example, you can imagine waving at someone. Meanwhile, Recoverix measures your imagined movement using an EEG cap. This movement is then simulated on the computer screen by a virtual avatar. This gives you the impression of actually moving your impaired arm. At the same time, your impaired muscles are electrically stimulated in real time, resulting in a real hand movement. Across 25 training sessions, you will imagine your movement a total of 6,000 times. It's about as many times as it takes a child to learn to walk. This combination of motor imagery and real movement execution is the key to Recoverix's success. It is never too late for a Recoverix therapy. We have helped patients 10, 20, or 30 years after the stroke. Schedule your first Recoverix therapy now at www.recoverix.com.
And this is a very short video that shows actually a Recoverix session. So it's basically as you've seen in the promo. So there are patients with different degrees of impairment, and most of them have benefit from the technology. I am not, of course, presenting this to sell you the product, but to show that BCI has finally some useful application that can be beneficial for actually a big part of the population. So until recently, BCI was mostly for completely impaired people, so to create a way for them to communicate. But now it's also spreading in the medical field, so into these more widespread type of therapies, but also in the non-medical field. Which brings me to my next point, the Unicorn Unity interface. In fact, I do not work on the medical products of g.tec. I work on the non-medical applications. We decided recently that video games are a very interesting use case for BCI. So originally, neurogames were mostly a way to allow, as I said, impaired people to still have some fun, enjoy the activities that normal people do. But now BCI is getting better. So it's not only aimed at this particular population, but it's also aimed at normal population. So really for creating fun and interesting experiences. And g.tec in this is a leader because we have twice a year, we have hackathons regarding BCI and video games that we also call Neurogames. And so we prepared a product called Unity Interface to facilitate basically the development of this type of application. So in a normal user BCI system, you have this loop. The user, of course, is part of the system, meaning that if you take the user away, you don't have a BCI, you only have a broken system. And then you have these 3 fundamental steps: data processing, feature extraction, and classification, which is actually one of the 2 hardest parts. So it's very complicated because it requires knowledge of signal processing, knowledge of machine learning, and possibly knowledge also of other domains in development of software. And then we have the feedback. Feedback is what connects the user to this system. The feedback is important as well. So it requires a careful design. Otherwise, the experience is not enjoyable for the user. Maybe you have a good classifier, but there is lag in the input-output. That's a bad feedback. The user does not get how to use this system, or it will be really annoyed. In a neuro game, the feedback is literally the gaming part of the BCI. I define Neurogame as a game whose mechanics are partly or entirely guided by the brain input of the player. So to me, a Neurogame is also, but also not just to me, to many people in this field, is any hybrid combination of brain input and other type of input, which can be a joystick, which can be another biosignal, which can be another sensor like an accelerometer. So those are all neurogame, all in the category. With the Unity interface, this is our goal, taking away data processing, feature extraction, and classification from the developer. Not really in a way that the developer cannot actually change some parameters, of course, but more like taking away the hassle of developing the whole pipeline, because that's the part that takes a lot of time. And so the developer or designer or creator, call it as you want, can actually focus on creating an amazing experience. So a very good neuro game. The Unity interface has 5 main components. So we have the BCI manager. This is basically the engine. So what's connecting devices, data streams, and propagates messages between all the other components. Then we have the pipeline controller. So at the moment, we have 2 pipelines. One is the simulation pipeline, and the other one is the signal quality pipeline. So those pipelines are basically a way to control the system. We have the configuration of each pipeline. So that's where actually the developer can act on the machine learning engine, on the processing, and change some of the parameters, so to customize the experience of the game. We have the neurofeedback target. That's the stimulation part. So it's basically the user interface, the part that interacts with the user, but from the BCI perspective, so the stimulation part. Because then we also have the BCI controller. That's basically just the UI elements, so menus and stuff that you usually need in a game to, to prepare the scene, to start the game. In this case, we also need to calibrate the BCI. So the BCI controller is where you will manage all of these controls. This is more or less the application flow. It looks complicated, so I will start from the backend. The backend is called g.tec chain. It's our embedded library, basically that does everything from signal processing to machine learning. And this chain has a bidirectional communication with the BCI manager. So they are exchanging continuously information. The BCI manager needs to be set up with pipeline controllers, and for each controller, a configuration. Then we have the BCI controller, which is the menu that can be used to control the BCI manager. So with a very, more intuitive way, rather than scripting, you just, link buttons and trigger functions. And then we have these neurofeedback targets. So those are triggered, controlled by the pipeline, but the events are propagated by the BCI manager. By events, I mean classification events. So the pipeline will control the timing of these targets, like turning them on, off, and following a certain type of stimulation. And the BCI manager will, on the other hand, provide information about the classification output. So this Unity interface at the moment works with event-related potentials. So it's not an active BCI, it's a reactive BCI, meaning that you need to stimulate the user to create one of these potentials. So whoever is in the field of BCI or neuroscience knows what is an ERP, and most importantly knows the P300. So the P300 is one of the most famous because it's been studied a lot. And it's this very peaky wave that you see, and it's caused by a not-hold paradigm, meaning that the user is presented a series of elements. One of these is a target, the other ones are not, and then repeat. So when the target is seen by, or listen as well, because this P300 actually comes from me listening to beeps, so some kind of sound beeps. The improbability of this event triggers a reaction in the brain. So this reaction is the P300. And there are a series of reactions. So for example, if we create congruence or incongruence, we actually have a -400, so a very strong negative peak. We have P300 that can be caused by engagement of attention instead of improbability. And we have similar waves. Also, we've seen that there are some event-related potentials triggered by recognizing a human face. So we tried making a P300 speller with famous people, and it worked way better than the standard flashing. Of course, you cannot use famous people in every application, but it's interesting to just see that we still have a lot to learn from these ERPs. Anyways, this is the basics. Then some more complex ERPs are triggered with different types of stimulation. So usually for the game, we decide to pick ERPs who provide a higher information transfer rate. The ITR is basically how many symbols the BCI can communicate per minute. So like the bit rate, basically. With visual flashing, those are the most studied in literature. And the three most used for performing BCI are the time-modulated ERP. So this is very similar to the P300, but it's not based on the oddball paradigm. Then we have the frequency-modulated VEP, which is also known as state steady VEP. So it's like a flickering of light at a certain frequency. And then the code-modulated VEP, this is a newer one. So it's looks like a combination of the previous two. We also have some ERPs who are derived, meaning that with the same type of timing flashing, you can also use other type of stimulation. For example, the motion onset VP is caused when you're moving objects instead of flashing light. You're moving objects. The auditory ERP is the one you've seen. My reaction to another ERP is when you're listening to sounds in following some kind of frequency. And vibrotactile ERP, for example, is a vibration. You can also time the vibration, for example, of a controller or a joystick. And those all elicit ERPs in the brain. Now, I will explain a little bit truly how the three main work, because it may be a little bit confusing. So first we have the time-modulated ERP. So this is basically presenting targets following a sequence, right? So the first target is the first one, second target comes after, third target again, and this is done in a cyclic way. So you don't need to follow the same order for each cycle, but no more than one flashing. And this line represents the on and off of the flashing, right? So in this case, here is on, here is off, and you follow this sequence. And this is a type of ERP that you have in the brain. So it's not exactly a P300, it's slightly different, but the same concept applies. Then we have the FEP, so the frequency modulated. So this is basically flashing targets at a locked frequency, like 10 Hertz, 20 Hertz, 30 Hertz, right? And then in the signal, what we can see are peaks at the frequencies that are actually triggered. So for example, the fast one would be a higher frequency and the slow one. So right now here I put the wrong number. This should be 3 or 2 and this should be 1. But yeah, the concept is that you just focus on a flickering per time. And then we have the CVP, which is based on this M sequence. It's a binary pseudo-random sequence that defines the timing of the flashing. So it's similar to the FVP in the sense that there is a flashing speed, a very high flashing speed that creates some kind of phase in the brain, but there is also a time component. So they are also shifted similarly to the time-modulated ERP. And this creates a phase shift that can be classified. So this is the type of ERP that results from a CVEP. And it's completely different from the other two as well, but the same concept applies. So there is always an onset of an event, and after this, you measure the phase shift to understand which target was. Each of those has advantages and disadvantages. For example, the TRP is easy to train for the user, usually has a good performance, and it's also usually stable. Like after you train, it's pretty stable. Its main disadvantage is that it doesn't scale very well with a high number of classes. That's because each class has to flash a single time during the cycle. So the more classes, the longer the cycle. Then the SSVP, it's amazing for training because there is little to no training. The performance is still very good, but the problem is that you're limited by the frequencies that you can actually target. So depending on the refresh rate of your screen, depending on the sampling rate of your device, you cannot really have many frequencies because you cannot pick, for example, 10 and 11. They're too close. You need to have some distance between each frequency, and that means that you don't have as many classes as the other ones. CVP is the one that has the best performance with a high amount of classes. So it's also known to be the ERP that can provide theoretically the higher information transfer rate, but it's a bit harder to train for the user. It can be annoying, irritating, and that means that if the training is no good, the performance is no good. So there is like a trade-off when choosing each of those. All right, I think we can move. And it's time for the hands-on session. So in this link, you will find a little game that I developed yesterday. So you can just clone it on your laptop and open it in Unity 2022.3. I specified the version because when Unity has a major update, usually something changes in how they handle materials and lighting. So in theory, it should work with older versions and it should work with newer versions. But every time you do this type of change, you will have to solve some issues. So I recommend using this version here. Maybe I should copy the link in the chat, or what do you think?
Yeah, right. Michele, you can drop the link. I think someone sends a link to the chat already.
Is it already in the chat?
Yeah.
Good. Okay. So I can exit the presentation mode and grab Unity. Okay, so far so good. You have any question at this point? Good. I will assume there are no questions, or I should read the chat probably. No, okay, perfect. So, but feel free to raise your hand and stop me if you have any questions. Let's go on the game. All right, for this game, I was very creative and inspired, and I took a classic game, Pong. And thanks to my amazing creativity, I decided to rename it to hockey, which I guess makes sense. It reminds me of the air hockey that you find in the arcades. And I want to show you how this game is so that you understand all the components. This disc, it's actually a brain because I like the theme of the brain. And you can customize the speed at which it travels and also the start position, but I don't think you will ever need to change that. The player is this blue paddle and has a speed and also discrete speed and bounds to keep them in line. What does it mean, discrete speed? It means that I already developed two ways of moving it. So let's try it. So this is continuous speed. So this moves up and down. If I hit the space bar, the CPU is playing with me to this Pong game, right? So straightforward game. I didn't put any scores because I was lazy. So you will keep your score in mind. The discrete movements is a different implementation of the same thing. So instead of moving the bar continuously, I have three positions, top, middle, and bottom, where I can move. And this is a way to make the game probably a little easier, or at least to give the possibility to make the game into a discrete problem. That has to do with how we build the PCI. So we can decide how we want to build the PCI, and we will see the differences in both type of inputs. Then we have, well, the CPU is, you can customize the speed of the CPU to make it more or less reactive, and also the trigger, like the position where the CPU starts moving. So basically, if you put the trigger in the middle, the CPU is a big cheater. It will always get the ball. If you put it closer, that means it has less time to reach the target. And those are the anchors where I move the bar, so nothing else important to see. First, we start with an empty scene because I want to show you first how to import the Unity package. So in theory, if you downloaded the Hybrid Black suite yesterday, you should have two softwares. Maybe I will go through that right now before actually building the game. So this is the Hybrid Black suite. We released a beta yesterday, so there might be some little bugs, and I hope those are not impacting too much in case. But you have a tab for connecting your unicorn if you have already one device. Otherwise, never mind. A tab for activating the licenses. I will show you now the license that you need to activate. This license, you have to keep, you can use it until the end of the hackathon. So it's already issued to last until that day. I will put the key here in the chat. Let's see. So this is the key. To activate it, you click on add, you put the licensing key here, you write the name of the product that you want to activate. In this case, it's the Unity Hybrid Black, also in the chat. And then the email is my email. So this is my hackathon license. So you have to put my g.tec email, which is also in the chat. If everything goes fine, you will have the license for the Unity interface, which comes as Unity package. And the other one that I recommend you download is the recorder. Give me a sec. And there are other tools that you can explore, like I will show you now. Many of them are for free, so you can just keep using them after the hackathon. So this one is the license for the recorder. I will show later how to use the recorder for collecting EG signal and checking the quality of the signal. So in this tab, you have some dev tools. So many of these interfaces are for free. I think all of them, many of them are for free. Simulink for sure not. Others are on our GitHub. So depending on the language, we also have an Android interface now. So we are expanding the portfolio. And those are applications. So the most important, at least for me, is the recorder. This one allows you to stream EG data from the unicorn, check the quality, apply some filtering to see what happens to the data. So it's usually important to set this up, especially if you're doing research, to check the quality of your data. I will show you later how to do it, because at the moment we only need the simulator. So assuming you have downloaded this game or you have an empty Unity project, you can right-click on the asset folder, import the package, and you will have, where did I put it? No. You will have a package named something similar, like Unicorn Interface version alpha, because it's still an alpha release. And you just pick it and it will prompt you to import the assets into your scene. All right. So you simply just do that. And it should also ask you to import Text Mesh Pro. And please, if you find any bugs while following this tutorial or next week or during the hackathon, you can report them to me, to my email or personally during the hackathon, because we are still debugging some of the features. Anyways, after importing, you will have this folder called g.tec, okay? There is already an example scene if you want to try, but I recommend starting from scratch so that we can actually have some fun. So in the Unity, in the plugins folder, there is the g.tec chain or the other libraries that you don't need to remove from the projects. Like you should keep those there because they're handling the low-level stuff. In the Unity interface folder, in the SDK folder, you find the open source scripts. And some of these are worth mentioning. For example, the UI controllers, so the one controlling the UI elements, also the PCI controller can be fully customized as you want. And then the stimulation. So we put 6 types of stimulation. It's actually 3 for 2D and 3D. So we have flash 2D and 3D. We have motion 2D and 3D, and audio 2D and 3D. I will open one just to show you that during the hackathon, you can do one thing, which is extending. Here it is. So this, if you create a new class and you extend your feedback target, you get all the functionalities of this interface, and then you can customize what happens when you trigger the stimulus. Basically, you can create your own custom animation. If you have sensors, you can connect external sensors, for example, a vibrotactile sensor, and make it vibrate following this setting, right? So you can just change everything that happens inside the new feedback target and make it your own. This is for a bit of more advanced users, but I think it's going to be very useful for you. All right. After that, we move straight to the prefabs. So that's what you actually care about when you're starting. We already prepared a PCI system. Okay, so this PCI system is what we showed previously on the slide. So it already contains everything: PCI manager, flash controller, PCI configuration, and the signal quality configuration. So what you will see in the game is this. Oh, this is a little bit too tall. Maybe we can lower it a little bit. There. In the PCI controller, we have a battery, a data lost icon when your device is losing data. Classifier accuracy, this tells you with colors, so red, yellow, or green, if the classifier has been properly trained. And a signal quality bar, so this shows in, well, you can also customize the color, but green good, red bad, easy, right? Then in the PCI manager, we have to connect everything. So now it's already connected, right? But normally you need to connect the PCI controller to update the devices, the Bluetooth devices. And all the UI elements are not automatically connected when you drag the new prefabs. So only with the PCI system, you already have everything connected. Otherwise, you can wire them yourself. Now we do a little test to see if I didn't forget anything. Oh yeah, probably the even system, which I always forget. This one is to register input from the mouse, so it's not related to the unicorn. So as you can see, here you have a list of serials. This drop-down, this PCI manager will look for the paired Bluetooth devices. So in this case, I have one real unicorn, and all the 0001 devices are simulators. So you just pick one, and these only simulate the connection to the device and some fake data like scene wave, just to, I probably have to set some object. Yeah, of course. I forgot to put any neurofeedback. So in the simulation folder, we prepared 2D targets. We love 2D targets, but mostly because they are easier to make. But they can also be 3D objects. Like you can just add this flash object class to any object and link it into a neurofeedback target. So one of these has to be a training target. So in this case, I'll put this here. Here. So the training target is the one that you want to put in the Flash controller on top. And the others, you will put them here. So right now we have only 3. So I need all the empty spots. Oh. And the other important thing at this point is to assign a class number to each. So 1, 2, and 3, because you can only have one target for each class. Then the other important thing is to configure the Flash controller. So we have our PCI configuration. The number of classes has to be higher than the objects that you put in the Flash controller. But also, if you put a different number, so if you put 20 into this box, it's like you're saying there are up to 20 classes. So you need to make sure that the number that you put here is still included into the maximum amount of classes that you set up here. So I will say that 10 are fine. Okay. And on the VCI manager, yes, you can have multiple pipelines. So for the moment, stimulation is one, as signal quality is the other one. You just drag the prefabs in here with your configuration, your Flash controller. So that would be pretty simple. I hope I didn't forget anything. Okay, so after a while, I should see some information, right? So this is telling me that the fake data are actually coming. If I start my training, the training object will start flashing with the paradigm that I choose. So right now I took the default configuration, which is an ERP, but I will show you how to change it right in a moment. Probably I put too many trials. So another important thing that you have to keep in mind is that vsync has to be enabled, because otherwise this happens. Like the flashing goes too fast, and underneath you're going to lose triggers and create jitters in the system, and as well the speed of receiving data is too fast for the classifier to work, right? So vsync enabled. And I picked Flash objects, but if you want to pick audio objects, you have to make sure you add an audio source. So we created a folder with some audio sources in sounds. They are scene waves, so not very pleasant, but you can try with that to begin with. And the other cool thing is what you can do with these Flash targets. So you can, so far we've written 0 lines of code. And you can keep on doing that because you can use these events. So when there is a classification event, the onActivated of the respective class is triggered. So you can connect an action here. And when it's released, the onDeactivated is triggered. Okay. And you can also customize for each target how long they have to be focused on. So it can be 0 means immediately. 1 is roughly 1 second, 2 is roughly 2 seconds, meaning that you can create objects with an increased level of precision or difficulty, depending on what you use them for inside your game. Now, if we go on the signal quality configuration, we mostly don't want to change any of these parameters. So that those are meant for people who know what they are doing, because this is basically defining what is a good signal. And most of people just don't know. So these default values are fine. With the BCI configuration instead, you have more options. So the training has to be at least 30 trials. We put a maximum of 200. I honestly never use 200. I always use around 40, 50, depending on the application. You can change the speed flash, but that's also affected by the number of classes. If you remember what we explained before with the cycle of the targets, if you only have 3 targets, and here you specify 3 classes, the cycle will be super short. If you specify 10 classes, it means that the cycle will be slower, but the application can, at runtime, add more targets. So depending on how you want to implement, you may want to keep this low, but if you keep this low, you probably don't need to increase the speed. Like it's going to be super fast anyways. And then we have the low pass filter cutoff. So this is the bandpass filtering, and it's an important parameter simply because as it's written in the hint, it's better to use 10 Hertz for ERP and 30 Hertz for CVP. Here you can change the type of simulation. We didn't put SSVP yet. We are still finishing it, but you can already use ERP and CVP. Here you have the selection threshold. So basically, how precise you want to be your classifier. If the confidence of the classification is lower than 85, you're never getting a classification event. If it's at least 85, you will get it, meaning that 85 is it's easier for the classifier, right? The classifier is going to give you more output with 85 of confidence. On the contrary, with 99, you will only receive the output for which a classifier is basically almost sure. So you have to play with this, but I recommend starting with 85. If there are too many false positives, then you increase to 90. You never want to use the 99 unless it's for some critical and precise application. For most of the games, 99 is too high. So you're gonna have just very little output from the classifier. Then you have this save data, CSV. This is creating a raw data file containing all of the information of your session. So EG data and triggers, basically, also depending on how many classes you have, etc., etc. And also another file containing the class probabilities. So this is very good for researchers if you want to save your data, create a little experimental protocol within a game. So it's possible to do that if you're using IRP or CVP and eventually SSVP later on. And what else? Oh yeah, there is also another event that you can subscribe to, which is called the data available. So this data available pulls data from the stream, meaning that if you want to customize your application and put some outlet, like LSL outlet or UDP outstream, you can in real time outstream the data. That could be, for example, redirected to Physiolab or to other visualization tools in a way that you can visualize in real time, either your raw EG or power spectral density or other information while the game is being played. And the last thing is the advanced settings. So I don't recommend changing those because they are for people who know what they're doing regarding PCI mostly. But you can customize the duration of the pre-trigger and post-trigger event. How long is the on-off time for the ERP at least? So normally off time is double the on time and it's calculated. If you activate this function, this will not matter anymore. Like this user flash speed will not matter. This one will be the one leading. You can also change the order of the filter and the regularization of the model. You can also change the synchronization mode. So this is the least recommended change. So we synchronize the BCI either with the frame rate of the screen or the timestamp. So the frame rate means that if you have jitters, the BCI is still going to keep synchronization, but it's going to have worse performance. And the timestamp means that the BCI will be timed. So if you have jitters lag in your computer, you may not have a successful training, but if you do, it's going to be super precise. So something to keep in mind, but probably none of you will use it during the hackathon. This is mostly for researchers. Okay, now I want to show you quickly the scene that I prepared with within the g.tec chain. Sorry, Unity interface, to show you how to use the simulator of input. So on the BCI controller, if you tickle this checkbox, you will have simulated input so that you can develop your game without connecting the device all of the time. You can develop all the game mechanics and try them out, and without connecting, disconnecting, and having somebody wearing the headset. So here, which object is not set to an instance of an object? Probably maybe in the Flash controller. Ah, yes, here there is. Exactly, so you should not leave empty elements in this list. You can replace them, you can change it at runtime, but when you start the application, just put the same number of the elements that you want. All right, so let's simulate a training. This sync is enabled. Actually, we don't even need the training. I can just show you what happens, right? So this is simulating class 5, this is simulating class 7, but no event is being triggered. I'm just showing this green target that you can fully customize to whatever you want. Only shows which target you're focusing on, but does not trigger the event per se, because there is a threshold. The threshold is specified on each object. For example, for this one is 4, for this one is 1, and our simulator needs to have a higher threshold, simulated threshold, right? So now it's triggering an event that animates this object, right? Okay, let's put all pieces together into our hockey game, brain hockey. All right, let's see scenes, simple hockey game. Yeah, I was already making the game fancier, so with lasers instead of static colors. Good. I like it better with lasers. And so we need to drag in a BCI system, which is exactly here. Voila. Okay. Probably exactly. The interface is going outside. Yep. For some reason, my signal quality bar has disappeared. Probably has to do with some Z transform or something. Ordering layer 0. Yeah. I'm not a very good 2D game developer. We note this maybe more in the middle, so it's not going to be too annoying for the game. All right, how do we do it? It will be a not so elegant solution, but we can put targets in the game, right? So not elegant because these targets that I prepared are not fitting the style of the game, but that's only, again, something that you can totally customize. Maybe I should simply put the hockey field on a -1 layer. That would solve all my issues. Okay. And one is here. Duplicate. 3 -3. I just remembered by heart how much was the distance. And all right, so we have our flash targets. Now we want to set up VCI manager, VCI controller. So we should probably drag the VCI manager to this VCI controller so that the buttons will work. These buttons that we only see in the preview of the game. And what else? The targets, of course. We need to put one target for training. And all of them inside here. All right. So selecting the class would be doing. And also focus time, maybe is 1 second. At the moment, we can change it later. So now we just have to connect some function. I already created some function for moving the bar, as I showed before. I have the discrete movement and the continuous movement. So let's see first with the discrete movement, because this is not so hard. Oops, it was the player. All right, so it would be move to anchor, and I counted them as 1, 2, 3. So 1 is top, 2 is, so this one should be 2 because 2 is middle. This one is on top, so we should be moving the player to the anchor number 1. So it's some kind of workaround. I make this game very quickly, so please don't judge if it's not a very clean solution. And player. Anchor number 3. So we are ready to test with the simulator at least. All right. I forgot the event system for the mouse click. I knew it. Okay, good. Now, let's see. Ah, yes, I probably have to activate the input simulator. Okay, we should put a higher threshold. Right. All right. So this is discrete movement, right? And considering I took maybe 2 hours to develop this game, 15 minutes to put the BCI, we just made a BCI game in a couple of hours, roughly. And if you already have a game, making the BCI is a matter of minutes. Then, of course, tuning, configuring, and creating, beautiful looking targets all takes time, but the basic of the BCI is there. I want to test this game now, so I will take a break from the Unity development and show you how to set up the device on yourself and how to check the data with the recorder and how to play with this game. Any questions so far? Good. So I have to remove my headset, meaning that I will redirect the audio to my laptop. How do I do it? More. Seems like I'm a little lost with the interface when sharing. Can I change my audio device without exiting the meeting? Like, is there a way of that? I'm a
Nicola,
bit.
can you say it again?
I would like to change my audio output device because I'm going to remove my headset for wearing the unicorn.
Oh,
So
yeah.
can I do it without leaving the meeting?
Yeah.
Because I'm kind of lost in all the options.
So you're gonna unplug your audio?
Well, this only. Let's see if I turn it off and it works.
Yeah.
Talk?
Yeah.
Perfect. It was easy as that. All right. So how to wear the unicorn. This is my friend Hugo wearing a unicorn device. You can see this is how you wear it. And there are two electrodes. These electrodes goes behind your mastoid, so behind your ears. How? We will provide these thick electrodes that you have to put behind. Now I already have mine. So I'll simply take another unicorn, turn it on by holding 4 seconds. 1, 2, 3. Good. Oh, well. Never mind that part. So one on the right, one on the left. So with these electrodes, it's very important that you make them go through your hair. So actually, it's also important that you can lock your strip. So that the contact stays good. You can just gentle rub them onto your hair. So if you have a lot of hair or very thick hair, you may need some gel. So in this case, I will try, and I have quite long hair. So it might be not sufficient to rub them inside. On the other hand, if you're bald, you are a perfect subject for this type of application. So let's open the recorder. All right. Should resume my sharing, right? Okay, now you can see my screen as well. And in the recorder, you press play and you start seeing the signal. So I will shut for a moment. It's a bit noisy. That's normal at the beginning. So one important thing when you do this type of experiments is leaving the device for a couple of minutes on the head. Also instructing the person to stay still, at least during the calibration, is important because that's the crucial part for the BCI. You can see on the right this brain indicating the signal quality. Actually, we have the same asset in the Unity interface. Oh, I might not have charged the battery of my device. Oh. So this very same asset, you can just drag it into your Unity scene. Okay, the quality is getting better. So this is all dry. If I put some gel, I have a syringe with some gel, you will see immediately like that the quality becomes much better. And I personally am preferring dry runs, but when you're doing research or when you're testing things, it's important to make sure that the quality of the signal is not the problem of your application, right? So if your application only works when you have gel, then there is some interference going on around, there is something wrong with the setup. So it's important. So if you have gel, you see the difference immediately. All right. Okay, more on 5, and we are ready to test. No, there is something wrong with my device today, for sure. This is not normal EG waves. Okay, better. As you can see, it's very sensitive to movement. Today, I don't know what is this type of artifact that shows here, but here is the good signal. Maybe some, well, I don't know. Okay, it's gone. Good, can go back to the Unity interface. And a little of BCI configuration. So let's start with ERP. I want to turn off the light. I don't want to be flashed. Number of classes, probably 10 should be fine, even less, like 6. And confidence 85. So let's start with these parameters and see how the BCI works. Now I connect to the real device. So the order of the electrodes is 1, 2, 3, 4, 5 to 8. And the 1, 3, 5, and 1, 3, 5, and 7 are the midline. Then the odd numbers are on the right, and sorry, on the left, and the even numbers are on the right. I think it did say something wrong. Actually, all the numbers on the sides are even, and the midline is odd. All right. Didn't get a classifier for some reason. So if you get a classifier, this should have a color. So I will check if it's only a UI missing element. So classification, division result. Sometimes Unity, when exporting packages, shows the connection of these, but it's not there. So I also recommend that if something doesn't work as expected, to try delete and recreate this connection. It's a Unity thing. We cannot really do much about it. It's how they handle the ID of the elements. Hmm. There might be another reason, which is frame dropping. So I will export these into an executable, because the Unity editor with all the streaming now is probably jittering on my PC. So yeah, it's important not losing frames in these types of applications, because otherwise you may lose important triggers, and we're building a system for recovering them, but it's not yet in place. Oh, this is not the right scene. All right. There's also something strange with my data. Pretty strange, actually. Sorry, I will check again with the recorder. If I cannot get stable data, I cannot get a classifier. So if I'm losing data for some reason, no, looks fine. I will also make the training a little bit faster because otherwise we spend too much time into this. Okay. Well, it seems like I'm not getting a classifier today for some reason. I did prepare the scene as well for wait, in case of failure of Unity. So I will just switch to that. And then wrap up today's lecture. Okay. All right. Let's see. I don't remember which. No. Brain hacking. Yeah, this was the one. Mesh controller. Okay. Configuration. Fine. Let's go for this. Oh, so there must be something that I broke in the other component. So when I get this green color, means that the classifier should be good. Okay. Also, you may have noticed that the color of these materials is different. It's because we provide these flash materials and flash objects, but you can actually change them. Like you can modify those. You can have your own. The only thing that we know from research is that a pattern works way better than a solid color. So for example, if you're flashing, black and white on and off is not going to work as well as black solid and black pattern. So the more dense is your pattern, theoretically, and the better it is. For 2D objects, we also have a trick. It's the rotate function, so we can rotate them along the z-axis. That's good. That's good for the classifier because basically your brain sees more images of like more versions of the same image while training. So it basically makes the classifier more robust. All right, now I can turn on the application, so the application mode. Okay, because this time I had implemented with continuous movement. So it's gonna be pretty hard to play, but I will try. Ha, the AI is helping me. Oh, come on. But the AI really doesn't want to win. Oh, I got it. Okay, I think that's sufficient to show you how the BCI works. So yeah, it's mind control. And the game is also pretty easy. As you can see, the angle for hitting is very simple. And I just want to show you the difference with a discrete movement, because I had implemented it before continuously, and then I realized it was complicated. Especially if you speed up the object, the continuous movement is not very simple. So in that case, there are two approaches. One approach is to tweak the BCI. That kind of makes sense if you think about it. So instead of using ERP, maybe using CVEP or having a lower threshold for focusing or for the confidence. So there are many parameters that you can change to make your BCI faster, but this is at the cost of usually of the precision. So maybe you may have some unwanted movement because it goes too fast. Anyways, it really depends on the pace of your game. Otherwise, you tweak the game. So in this case, I already had slowed down from 5 to 2, the speed of the brain, which makes it pretty playable. So in this case, maybe the difficulty can come from another element in the game. So not really the ball moving, but maybe there can be some distractions or some objects coming out, or one of the controls may be debuffed, so disabled or slowed down by the enemy. And so really up to the game developer to decide how to do that. 3. Okay, so now I put on a discrete system, which you will see is probably the best solution for this type of game, but not necessarily, just my preference. Medium classifier, well, let's keep it. Okay. Oh. Ah, I should have made the AI more intelligent. I think I could have made the focus time slower because I'm not getting many false positives. So I'm satisfied with this BCI performance, top, middle, oh no, bottom. Oh. Okay, with a medium classifier, I'm still able to play this game and, well, for the moment winning. because I kept the score in my mind. And that's it for the Unity tutorial. If you go to the repository, there will be a merge of my BCI integration on the main branch, but after the hackathon. So until the hackathon, you can find two branches. One is main, where you find the empty game, so that you can play and with the BCI, like creating the BCI from zero. And on the BCI integration, you will find this already made, so that you can compare, you can actually see if you've done anything wrong, or like me, debug your other implementation of the game. All right, let's go back to the presentation. There's still a couple of things that I want to show you before wrapping up. I have 3 minutes, and we started 5 minutes late, so I have 8 minutes, but I will take way less. If you have questions at this point, again, feel free. Otherwise, I'll go on. So, what do we have already in the Unity interface for you for this hackathon? Well, we have the motion on set VP. So here you can see that I'm focusing on moving targets to trigger the BCI. And it's even better now. So this video is from January, which is a long time ago in development time. And now we made it more stable, and it works also with CVEP. So with CVEP, you can do the same thing. It looks more like a vibration. And the advantage of the motion on set is that you can make, I think, nicer animations from the game point of view, but also it's less fatiguing for the eyes instead of the flashing. And the other one that I want to show you is the auditory ERP. So in this case, now probably you will hear my audio from my computer. You have to focus on one of the sounds, and that basically triggers an action. So the user does not necessarily have to look at the targets or at the screen. This can be useful, for example, for spatial movement. If you have spatial sounds, it can be used in some music-based games. So it has some utilities, and also for people who maybe have vision problems. So those who suffer from epilepsy should not play the flashing BCI. So maybe for them, this is better. Also for those who have a problem like just for a near sight. So these are the sounds. You can totally customize the sounds as well. So you can make it lower and play some kind of rhythm. What I don't recommend is to use this with the CVP, because at that point the sound is too fast. It's like you just only hear noise. So just don't. It's possible to do it. We don't software lock this feature, but it's not really recommended. So I have also some guidelines for you, but it's basically a summary of what I already have said. So understand the constraints of the BCI. So you first try and try many times. Try with gel, try without gel, try with more than one person, because there are some people who are naturally good BCI players. There are some who are trained, so they know the BCI and they know how to use the BCI, and some who are completely unable to use it. So make sure that you test with all type of people, and also that in the case of people who have troubles using the BCI, to simplify for them the gameplay, so to assist them in using the system so they don't get frustrated. So around the affordances of the game. Of course, you have to pick the right paradigm based on the game. So if it's a slow game, fine, ERP usually is work for all. But if you want a faster game with more elements, then maybe you should shoot another one, so CVP. In any case, avoid to have many classes. Like you almost never want to have 30, 40. Our maximum, like theoretical now, is 60 classes, but the only case that I see for such an application is some kind of speller keyboard. Apart from that, so apart from communication of symbols, there is not really much in a game. Like if you have a big scene with many targets, you can just move them around. Like you can fake that there are more. You can just move them and change what they do based on where they are. So you can actually design the game around a fewer number of targets. Also try to gamify the calibration phase. I didn't do it in this case because I didn't have time, but if you gamify the calibration phase, the game already becomes funnier, like having to every time calibrate just by looking and not understanding what's going on. Like people who build the BCI often are not the people who play the BCI. So if you can gamify this part of the game, you can probably mix the tutorial of the game with the calibration, or you can use the time of the tutorial to calibrate the BCI without the user even knowing sometimes. Like we want to see the creativity in this case. And some people already done it. So in one game built by a partner team, they were using the background to show the quality of the calibration. So basically during the calibration, they were telling the player to gather mental strength, mental power. It's a game about telepathy and mind reading. And so they see the background changing, right? So that's a gamification of the calibration. And if the background became bright, that meant that a good calibration happened. Otherwise, we do. Also, as I mentioned before, for me, a newer game is also hybrid BCI, and I recommend using a hybrid game. So not make, unlike my brain hockey, don't make a only BCI game. Try to be clever. Try to use the BCI where it's needed, right? So honestly, moving paddle in Pong is just a flexing of the BCI. It's not really what you would want the BCI to do, like to just control the entire game. A more clever design would be you just play Pong normally, but then with the BCI you can trigger some bonus, you can trigger some actions, you can paralyze the opponent. So try to do this kind of design work around the BCI. Also avoid moving the neurofeedback targets. We did in some cases, it works, but if you move them around too much, it's hard to keep focus on them, but you will see. And avoid materials that are not very visible. So if you're using a visual stimulation, of course, avoid making transparent things that are not very visible, and like the difference between on and off is minimal. That's not going to work. All right. Now I'm going to show you, this is basically a trailer of the Unity interface that we are presenting at the GDC in San Francisco. So we're going to go there and show our product, and also what we made with this product and what can be made. So if you've noticed in this video, some of the clips contain this like headband-like device. So this is our new device with 4 electrodes that we are actually currently developing. We'll manage to bring some prototypes to the hackathon, so maybe some of the teams can already use it in their projects. So the advantage of this device is that you don't need gel at all, so there is no gel. And it can already be connected to a MetaQuest, for example, or without a MetaQuest, it's still very handy to use compared to wearing this cap. And so it's a prototype at the moment. The official release is set for this spring. At the end of the spring, we have a big event for g.tec called Spring School. You can Google it. There is another hackathon there, and also 10 days of lectures, like free lectures that you can just follow. And you may even get credit if you're students for those. But these are my emails. So if you need to write me about research, write me on the PhD email. If you need to write me about g.tec stuff, for example, submitting some bugs report or issues with the Unity interface, use the work email. If you are interested in my research, which is on BCI and games, You can follow me on LinkedIn. I usually post videos there and little clips like the one you just saw. I also have a new YouTube channel, so it's pretty empty right now, but I'm making a series on EEG analysis and classification. So for example, P300 classification, you can already find one video on how to pre-process the data with Python, and another one will be out soon on how to classify the signals. And all the tools from the YouTube lectures and also other tools for working with the unicorn are on this GitHub repository. So that's all free to use in your projects. And if you're a researcher, I also recommend these 3 books as references. Those are mine, at least. And especially the last one is very useful if you do a lot of signal processing. So that's like the Bible of signal processing. Python machine learning is a very good book that goes through scikit-learn to PyTorch and TensorFlow. So it's a pretty good book for everyone who is a practitioner of machine learning. And the first one is, I think, the most complete description of how to build a BCI, what to keep in mind. So if you have any questions, what are the available hybrid BCI architectures, the answer is there. So check out that. Thank you. And if you have at this point any question, this is the last occasion. Online documentation for the Unicorn Unity package. Good question. I reply to that immediately. So there is, so we are putting it out, we are rolling out this documentation. So there should be already something on GitHub. I didn't put the link because we are still finishing it, but by the time of the hackathon, so next week, you will have it. But the one you've seen today is the only up-to-date tutorial. There are tutorials on YouTube, but those are for the old version. We completely rewrote the entire software, so there is no, the old ones are not useful anymore. We are updating it.
All right. Any other questions? Great. Thank you, Michele, for the
Pleasure.
incredible g.tec unicorn session. And so g.tec unicorn hybrid black will be the primary device for this hackathon, typically for the first 2 hacking track, the cortex typing and the neuromancer. So this afternoon will be another session about Physiolab XR, which is a tool you can visualize, record, and replay the data in real time. Okay, so it will be 3 p.m. this afternoon. And tomorrow there will be another session about Unity. So if you don't have any background in a Unity platform, you can join that. And the speaker will be Ziyao Gao, a master's student from Columbia University. So he will teach you how to build a Unity project from the scratch. Perfect. Any other questions so far? Or Michele?
Well, I will. No, did somebody talk?
Perfect. So the session will be recorded, and we will have a link in our website, so you can rewatch it before the hackathon. So next workshop, I see a question here. Recommend to have hands-on computer. So for the next workshop will be Physiolab XR. So for that, we'll have a hands-on activity that you will open the platform and send some simulated EEG signals and do some signal processing stuff. For tomorrow's session, it will be a tutorial about the Unity platform. So it will be great if the participants could have the Unity Hub and the corresponding Unity version downloaded on their computer. So you can follow. Yeah. Okay. Thank you. And a quick reminder, so for this afternoon session, starting from 3 p.m., so the prerequisite will be some Python programming experience and the PyCharm IDE. So it's a Python editor, and you can apply the free educational license on their website with your institution email. Okay, perfect. So at this point, I would like to thank all your participation and engagement and the talk from Michele. Thank you.
Thank you so much for having me, and I'll see you next Friday then.
Perfect.